Greetings of the day from Asian Institute of Technology and welcome to the 19th technical session of Second International Symposium on Disaster Resilience and Sustainable Development. I am Ganesh Tungana, PhD student at Asian Institute of Technology, Thailand, and I'll be serving as a moderator for this session. Along with me, we have Ms. Kulanan, who is also a PhD student in Asian Institute of Technology, and she will be...
Warning in progress. Technical session 17, vulnerability, resilience, and sustainable development. I'm Nishma Dagar. I'm very happy to be joining
Just a minute.
this.
And meanwhile, I would like to inform you all that this Zoom session is being recorded and the recorded session will be made available on request. Please mention to us if you have any objection or so. Now, without further delay, I would like to introduce two dignitaries of the sessions. Their presence as a co-chair in the session is adding more value, and we are so much honored to have both of them. Now, moving along to our session, please join me to welcome our co-chairs. Our co-chairs, I would like to introduce our co-chair, Dr. Salvatore Vidis. Dr. Vidis is Assistant Professor at Asian Institute of Technology, AIT, Thailand. He has a background in applied geology. He obtained his PhD in geoinformatics and environmental science from the University of Siena, Italy in 2006. Dr. Vidis currently research interest center upon the use of geoinformation science and earth observation technology to a variety of environmental challenges and applications domain. He has more than 18 years of experience in academic environment and supervised several master and PhD candidates in European and Asian universities. We are so delighted and honored to have you, sir. Welcome to the session as a co-chair, sir.
Good afternoon for the nice presentation. And good afternoon. Thank you for the nice presentation and good afternoon to everyone.
Thank you, sir. Now, I would like to introduce our another co-chair. He is Professor Tabasambraza. Professor Dr. Raza is the Dean of Graduate School of Business and the Director of Disaster Management Unit of Philippines School of Business Administration. He is also the Special Technical Advisor of Quezon City Government. He is a professor at the School of Urban and Regional Planning, University of the Philippines. He has multidisciplinary academic with 25 years of internationally progressive working experience. His field of expertise includes sustainable development planning, climate change adaptation, disaster risk management, institutional setup, and policy design and financing. He has substantial number of peer-reviewed publications and had worked for the numerous international funded projects. We are so delighted and honored to have you as a co-chair of the session. Welcome to the session, Professor Dr. Raja.
Thank you for having me. And I'm very pleased to welcome all of you and thank you very much.
Now, our respected co-chairpersons will take over the sessions and will call the presenters for their presentations. Participants having questions regarding the presentation can post their questions in the chat box as we will have the discussion and Q&A session at the end of all presentation. Our co-chair will also facilitate the question and answer session and will provide their expert opinion on the subject matter that will be discussed during the Q&A session. Over to you, co-chairs, for the further proceeding of the session.
Okay, thank you. I would start as planned. Again, good afternoon to everyone. There are 30 plus colleagues here going to listen to 10 presentation output and findings of diverse researchers conducted by our colleagues and their working groups. Before we start, I would like to thank everyone to helping us in conducting this session, Ganesh, Kulanan. And again, it's my great honor to share this duty with Professor Tabasam. So no further delay, and let's start with the first presentation that will be given by Dia Samer. I apologize, all colleagues, if I make some mistake in the name's pronunciation. I will have a very strong European accent. So Dia Samer will be going to present a research titled An Explanatory Study on Feasibility of Materials for Refugee Relief Settlement.
Professor, one
Yes.
small correction.
Yes.
As we are playing the pre-recorded presentation and there will be no live presentations, we haven't received the presentation from Jia Samir. So
Okay.
we are skipping this presentation and we are going to the second number.
Okay, great. So thanks for this clarification. So we go directly to RRJ Chaturanangane Yaya Cody. I'm sorry. We'll be presenting a work titled How to Address the Housing Needs of Displaced, Promoting Resilience and Sustainable Communities.
Hello everyone, my name is Chaturangani Jayapati. I'm a researcher attached to Global Disaster Resilience Center, University of Huddersfield, UK. The topic I'm going to present here today is how to address the housing needs of the displaced communities, promoting resilience and sustainable communities. So the work I'm going to present here today is based on the research project called REGARD, which stands for Rebuilding After Displacement. This is an Erasmus Plus strategic partnership project. The project consortium consists of 5 different universities in 4 different countries. So today we are going to present part of the findings of our project. So the research context. The topic we are focusing here is on displacement. There are various types of displacement. We are focusing on conflict-induced displacement and disaster-induced displacement. And also there are various types of needs of these displacement communities, varying from economic needs, housing needs, social needs, and livelihood needs. Out of these various types of needs, in this presentation, we are focusing on the housing needs. Why the housing needs are so important. The housing factor acts as a social center for family and friends, a source of pride and cultural identity, a source that commands both political and economic importance. Therefore, addressing the housing needs of the displaced communities should be seen as a mode to promote resilience and sustainable communities. Instead, the lack of ability to link these factors to the housing provision can cause many issues, including no access to livelihood, poor living conditions, health problems, and lack of financial independence, and so on. So, addressing these research needs, this study investigates the factors to consider when addressing the housing needs of displaced, promoting resilience and sustainable communities. The research team of REGARD project conducted how we did this. I'm explaining here. The research team of the REGARD project conducted 47 in-depth interviews in 4 different countries with officials, community representatives, social support networks, agency networks, and so on. Apart from that, focus group discussions were conducted with the community members in Sri Lanka, covering both conflict-induced and disaster-induced displacement. Then we analyzed all these data and we validated through expert interviews, and we developed the final framework. Out of this final framework, we are here presenting only the part of the findings, which is the addressing the housing needs. So, what our findings say? Findings reveal that the housing factors factor acts as a significant role in rebuilding communities and determining long-term satisfaction of displaced communities. The result presents 7 essential factors to consider when addressing the housing needs of displaced communities, promoting resilience and sustainable communities. This means if we want to promote resilience and sustainable communities through the housing provision, we found 7 factors to consider. The first main factor is adequate provision of standard and quality housing for all the types of displaced people. Refugees and asylum seekers who gain access to housing is restricted, sometimes restricted by affordability, especially in big cities. This leaves them no choice but the likelihood of poor housing conditions. Therefore, adequate provision of standard and quality housing stays as a foundation out of these various types of housing needs and factors. The second factor is maintain the social equity and housing provision. Especially in the UK context, there are two main types of refugee channels. One refugee channel have to arrange for their own housing by themselves, but another channel of refugee housing is one of the components of the package they get through the resettlement scheme. The housing conditions also depend on where the asylum seekers have been dispersed to live in, with claims that some are good while others are not good. So there should be equity in housing provision for all the types of refugees who come from various refugee channels. Then the third factor is at the housing provision, we need to match the location of resettlement housing with socio-cultural and economic needs of displaced communities. So, social and cultural needs are not considered when displaced people are dispersed within the country. As an example, lack of religious places in some areas would pose a problem to displaced communities. Access to previous livelihood or place where sometimes access to previous livelihood we have to consider. Access to previous livelihood or place where the land or place is attached to livelihood and identity. For some communities, land or place is both livelihood and identity. As an example, fishery community or agricultural communities. No access to grazing land means for them they will be deprived of a livelihood and it will cause for loss of identity. So there's a urgent need of matching the location of resettlement housing with the social, cultural, and economic needs of the displaced communities. And then there's a need to match the size, layout, design of the resettlement housing with the socio, cultural, and economic needs of the displaced communities. Mostly, the size of resettlement housing is commensurate to the size of family, but some argue that composition with the family size, including age and disability demography of families, are not properly addressed. Housing, especially when we consider the disabled people, housing design need to cater the individual needs of the people, especially if the disabled people are seeking for self-employment. The housing size, design, and the layout should facilitate these needs of the displaced communities. And then fifth factor is relocate the displaced communities to suitable and welcoming neighborhoods, sometimes who have experienced the diverse communities or refugee communities. Groups are more developed. It's good to relocate to these types of welcoming neighborhoods. Displaced are housed in deprived areas with multiple problems and little or no experience of diverse communities. This can lead to social tension and sometimes racism towards the displaced communities. Then the sixth factor is promote social integration through the housing and the built environment. Sometimes it's difficult to create social integration, especially host and displaced come together with different backgrounds. So in these cases, we can arrange the built environment to often get together and participate in activities. The last factor is Increase the sense of belongingness and attachment to the community of both host and displaced through the housing and the built environment. The way a community's built environment is designed influences the physical and mental health of its residents and sense of belongingness. Therefore, it's really important to increase the sense of belongingness and the attachment to the community through the built environment. So these are the 7 factors, and thank you very much for listening to my presentation.
Thank you very much for the interesting presentation. I remind everyone that all questions should be submitted by chat box. We will be checking constantly the chat box, and then answers will be given at the end of all list of presentations. Okay, so now we go straight away to the second presentation that will be given by Muhammad Hamza Sabir. And the title of the work is Numerical Computation of Code Compliant Beam Column Joints Made with Low Strength Concrete.
Alhamdulillah. Greetings. I am Muhammad Hamza. Including for special objects, concrete, column,
I think audio still have problems.
This section of course.
Yes, sir. We have a problem with the audio in this presentation. Let's switch to another presentation and we'll try to fix the audio. Will that be okay, Professor?
I'm not understanding. Can you repeat, please?
We have an audio problem in this video presentations. Let's move to another presentation.
Okay, the next one.
Excuse me, if I may. Since it's my presentation, I have also submitted a PPT file and it has voice narration over it. That has a better audio quality. I don't know what went wrong with the video, if that's possible.
Okay, I'll talk to my technical team and we'll solve your problem.
Sure. Thank you.
Okay, so we can go ahead. We can keep this on hold, and then we go further. So next one will be presented by Rudrakshi Chaudhary. He will be presenting work titled Seismic Performance of RC Buildings with Concrete Made by Using Different Waste Materials.
All are doing well and safe. My name is Rudrakshi Chaudhary and I'm a BTech student at Pandit Deen Dayal Energy University in Department of Civil Engineering. And today I would like to present about seismic performance of RC building with concrete made by using different waste materials. So till date, there has been various studies related to the effect on mechanical properties of concrete on addition of different materials. However, handful of them focuses on seismic performance of structures made from such concrete. For this project, we considered 3 materials that can be added as a replacement of cement or other components of concrete, namely polystyrene granule, electrical cable waste, and recycled seashells. This study focuses on the seismic performance of a structure and on establishing a comparative study with the conventional concrete. Table 1 here shows the dimensional details of the structure developed in the software called ETABS for the analysis. The number of stories considered was 3 and the story height taken was 3 meters. Number of grid lines in both X and Y direction was taken to be 3 and spacing between grid lines in X and Y direction was taken as 4 meters. The grade of concrete was taken to be constant throughout the analysis for all the 4 composites as M25. Same was done with grade of rebar. 2 grades of rebar were used, Fe415 and Fe500. The figures shown here shows the elevation and plan of the structure made in ETABS. Table 2 shows the material properties like density and modulus of elasticity of concrete mixes that varied according to the waste material added. The material properties that were kept constant were Poisson's ratio and coefficient of thermal expansion. The loads assigned to the structure were exterior wall load taken as 17.25 kilonewton per meter. Partition wall load was taken to be half of exterior wall load. Floor finish load was taken to be 1.25 kilonewton per meter square, since floor finish load is taken between 1 to 2 kilonewton per meter square. Live load taken was 3 kilonewton per meter square. The seismic coefficient and site conditions are also shown here. All these parameters were kept constant throughout the analysis for all the 4 composites. While analyzing loads in ETAB, load patterns, load cases, and response spectrum functions were defined as evident in the picture. In order to check the behavior of the building, time period in each case was first observed. This graph shows fundamental time period, that is time period at mode 1 for all the concrete mixtures. It was observed that time period was maximum in case of polystyrene granule and minimum in case of electrical cable waste. Moving on to the results obtained, 3 parameters were observed. Number 1, maximum story displacement in X and Y direction. Graphs given here shows a comparative study for story displacement in X and Y direction for different concrete composites. It was seen that concrete containing polystyrene granule had the highest story displacement in both the direction of about 6.6 mm. Meanwhile, concrete with electrical cable waste has the lowest value of 5.2 mm for the same. The second parameter that was considered was maximum story shear in both X and Y direction. When the analysis was done using equivalent static method, maximum story shear in both X and Y direction was observed to be the highest in case of conventional concrete and lowest in case of polystyrene granule concrete composite. However, not much of a difference was seen while comparing story shear of concrete containing electrical cable waste and seashells, as shown in the majority of graphs here. Same observations were made when the analysis was done using response spectrum method. The last parameter that was considered was percentage of maximum interstory drift in X and Y direction. Highest interstory drift was seen for polystyrene granule in both X and Y direction, that is 0.125% and 0.15% respectively, while the lowest was seen for electrical cable waste. Coming down to the conclusion, an increase of 20% was seen in story displacement in case of concrete polystyrene granule composite, which exceeds the maximum permissible limit of displacement as per IS 1893. This might be because of formation of lightweight concrete or addition of polystyrene granules. Second point, incorporation of electrical cable waste in concrete was found to be the most feasible since it gave lowest value of maximum story displacement in both X and Y direction by response spectrum method. Story drift was found to be minimum in case of concrete containing electrical cable waste. Hence, addition of electrical cable waste makes the building much lighter and reduces base shear in building. From all the above points, it can be said that addition of electrical cable waste in concrete is the most viable option among all the cases that we considered here in terms of overall seismic performance of a structure. These are the references for the papers that we considered for the entire study. We'll be submitting the full-length paper shortly. These are the contact details. Thank you.
Okay, thank you, Ms. Rudrakshi, for your insightful presentation. Now we go to the next. Will be presented by Kiran Kumar S. He will be presenting work titled Resilience Master Plan as the Pathway to Actualize Sustainable Development Goals, a case of Kozhikode in Kerala, India.
Hello, my name is Kiran Kumar. My presentation is on the topic Actualizing the Goals of Sustainable Development by Formulating a Resilience Master Plan for City of Kozhikode, Kerala, India. Resilience is broadly defined as the ability to bounce back after perturbation and to return to a status quo. The need for resilience has increased with increasing effects of climate change over the years. Making cities resilient will help negate the cost to rebuild cities. The location of the project is Kozhikode Municipal Corporation, which was historically known as Calicut all over the world and is located on the northern coast of Kerala. The aim of the project is to make Kozhikode city a resilient and a sustainable city, providing a safe and livable environment by formulating a resilience master plan. The study is limited to studying the various dimensions of the city and the various disasters that can strike the city area. Our resilient systems have inherent qualities like reflectiveness, robustness, redundancy, flexibility, resourcefulness, inclusiveness, and integrity that make them resilient. These systems can be a single person to a community or to the entire world. Urban resilience is an ability of an urban system and all its components to maintain or to return to its desired state or to transfer from one stable state to another in case of a disturbance. Urban resilience can be assessed by identifying the various dimensions that are in their present scenario. These systems also have three equilibriums: a single state equilibrium where it returns to its original state, multi-state where it has multiple stable state and switches from one stable state to another, or dynamic non-equilibrium where it's constantly changing its state. In order to get to a stable state, they can take one of three pathways: persistence, which is when it returns to its original state; transition, where it gradually shifts from one state to another; or transformation, where shifts happen rapidly. Adaptability is the nature of disturbance that the system can face, and they can either be specified, which is narrow, or general resilience, which is much broader. Time is an important parameter. The sooner a system can shift from one stable state to another, the more resilient it is. While measuring resilience directly is not possible, you can gauge the resilience of a place by understanding the present state of its various dimensions. This is a method used by a resilience index, which can be used to establish a resilience baseline of a place. The Climate Disaster Resilience Index uses a questionnaire-based approach to assess the resilience of a place. It has 5 dimensions with 5 indicators and their various parameters, which can help establish a resilience score. While resilience and sustainability share many similarities, there's a prime difference between them. Sustainability is a normative goal for a society, while resilience is a non-normative property of that system to achieve the goal. Coming to the difference between master plan and resilience master plan, while master plan tries to achieve the goal of sustainable development systematically, resilience master plan envisions to achieve the goal by enhancing the resilience of a place in a systematic manner. The master plan for the city of Kozhikode was sanctioned by the government of Kerala in 2017. The vision and the goals focus on the economical and sustainable development of the city while conserving the traditional values and the occupations of the region. While the various aspects of the plan focuses on meeting the rising demands, one of the major drawbacks of the plan was that it did not focus on how the various disasters impacted the various aspects of the city, especially with increasing effects of climate change. Coming to the guidelines, the NDMP was formulated by the Government of India to tackle disasters at all levels of the government systematically, while Rebuild Kerala program was formulated by the Government of Kerala to rebuild the state in a resilient manner after the floods of 2018. The Sustainable Development Goals and Sendai frameworks were formulated by the United Nations to focus on sustainable development and disaster risk reduction, respectively, on a global level. Next is a framework to reformulate the Resilience Master Plan for the city of Kozhikode. The goal is to transform Kozhikode to a resilient city in all sectors, adapted to recover from disasters of any kind, while ensuring sustainable development with a strong and flexible economic base supported by a robust infrastructure network guided by an inclusive and efficient government and other institutions. While the concept combines the development aspects of a conventional master plan with the resilient nature of a disaster management plan. The process is divided into a study, analysis, and finally the reformulation of the resilient master plan itself. The city faces both natural and anthropogenic disasters, with some of the most recent ones being the Nepal outbreak of 2018, the Great Floods of 2018, the floods of 2019, the ongoing COVID-19 pandemic, and coastal erosion. The physical aspects of the city are plagued with a dense core, which is highly prone to flooding, narrow roads, inefficient and limited water supply and waste management, and improper use of waterways. The social aspect of the city faces issues like aging population and significant poverty in minority communities. The economic aspect of the city is in a state of transition from traditional to new age industries, and the city lacks redundancy in this aspect and also underutilizes its tourism potential. With regards to institutional aspect, the major drawback of this is the lack of a city-level disaster management plan and depends on dependence on a district level disaster management plan. One of the major drawbacks of the natural aspects is the lack of any local laws to enforce climate change adaptation and the threat of urbanization along the backwaters and wetlands. In the next step, this resilience of the city of Kozhikode is analyzed. The SWOT analysis was used to identify the strengths, weaknesses, opportunities, and challenges of the city with regard to resilience. In the quality of resilience analysis, the various sectors of the city were compared with the various qualities of resilient systems, and most of them were either flexible and resourceful, with just some needing the redundancy and robustness. The resilience of the city was established using CDRI framework next, and after talking and interviewing the various stakeholders of the city is determined to have moderate resilience scope. And also next, based on the available data, a vulnerability map was formulated using flood and coastal erosion maps along with population density. The next step is the formulation of resilience master plan for Kozhikode. The vision is a sustainable, resilient and livable city with robust infrastructure driven forward by a flexible economy and led by an inclusive and efficient governance system prepared to face hazards of any nature. The resilience master plan has two divisions. Firstly, a disaster resilience plan, which focuses on the aftermath of disasters and divides the city into high, moderate, and low vulnerability zones and identify the different relief centers and medical centers and evacuation routes to them. The next is building resilience plan, which focuses on building resilience in the long run and is categorized into robust infrastructure, flexible economy, inclusivity and governance, and sustainability. Coming to conclusions, understanding resilience is vital to help transform cities that are less vulnerable to disasters while striving to achieve the goals of sustainability. With the increase in the amount of disasters, especially due to climate change, by implementing the resilience master plan, Kozhikode city can actualize the goals of sustainable development. These are the references, and thank you.
Thank you, Mr. Kiran, for your interesting presentation. And before going to the next one, I would like to remind that the presentation to be given by Mr. Mohammad Hamza Sabir will be given at the end of the whole session. So next presentation will be given by Tingyuk Sekak, and the work is titled Spatio-Temporal Vegetation Cover Analysis to Determine Climate Change in Papua New Guinea.
Hello everyone, this is Dr. Seka speaking from PNG University of Technology. I'll be presenting on spatial-temporal vegetation cover analysis to determine climate change in Papua New Guinea. So we know that vegetation cover is thought of as one of the common controlling factors for climatic variables like temperature and rainfall. Existence of vegetation cover is more important when we talk about mitigating climate-related impact. This is when we talk about balancing the situation in terms of greenhouse gas emission and reduction. Vegetation is one of the geographical factors that usually plays an important role in regulating the carbon cycle, regulating the energy exchange within the ecosystem, and regulating climate change through photosynthesis. So doing investigation and having proper knowledge of vegetation changes within a region can ease better understanding of different land use type and then to more methodically grasp the Earth's climatic system. This can efficiently help develop more sustainable strategical plans and policies for efficient ecosystem or environmental management. Investigation of climatic variables like rainfall and temperature and then evaluating its relationship with climatic variables. These are the common research around the world. So this such research creates a good gap into visualization and understanding how climatic factors influence vegetation cover over time, that is in a long-term scale, in a short-term scale, how changes in vegetation cover influence our weather patterns. Climatic conditions are also influenced by vegetation change from time to time, and in more to that, the climate conditions of previous time, including the present climatic conditions, they also have an impact on vegetation growth. So the main aim of the current research are to explore trend and variability of vegetation cover over time and then to assess its relationship with climatic variables. And then these are the objectives that will be active in this research. These are the study areas that are comprised of 8 provinces within Papua New Guinea. The study area is mostly terrain, as you can see here. So this is the methodology that was followed into achieving those 3 listed objectives. So before evaluating the NDVI trend, we first have to understand the type of land cover within a study region. So this map can further assist into that. So when we look at the annual mean NDVI, we have found out that the NDVI has decreases towards the highlands region. So where the darker red areas or light red areas, these are areas that shows lack of vegetation cover or unhealthy vegetation cover. The more darker areas, they shows the good vegetation, healthy vegetation cover. These are the area in percentage highlighting the high vegetated zones or low vegetated zones. There has been slight decreasing trend observed from 1981 up to 2015. When we calculate the trend, figure A here represents the magnitude of change NDVI unit per year. The browning areas is how much it has decreases over time. The greening areas is how much it has increases over time. So figure B here highlights the significant decreasing, which is the browning areas, significant increasing, which is the greening areas. So it can be concluded that there has been more decreasing than the increasing. So the graph here shows the percentage of pixels that shows decreasing trend and increasing trend. So there has been 1,492 pixels has been evaluated within this study region. So we have found out that the zones that are observed to have less vegetation cover needs 3 replanting enforcement program. So zones of significant decreasing trend has to be made aware to the growing communities to enforce minimize practice of deforestation. So current research can be used as a tool to better protect and conserve our virgin forest that is slowly depleting. So this is the annual mean rainfall and temperature distribution within the study region. We have calculated the Pearson's correlation coefficient to identify the common relationship between the NDVI and temperature. It was found out that more zones with positive correlation, which is the browning areas here, seen significant than negative correlation, which is the green areas here. This is the correlation significance p-value that was calculated. Highly significant, which is the more green areas, to insignificant, this is the light yellow here. So the findings is like the positive correlation towards higher regions was due to over time low temperature that has created an atmosphere that complicates the process of good vegetation growth. So positive correlation again towards low-lying zones. This was due to increased temperature that enhances respiration and photosynthesis for good plant growth. So negative correlation towards low-lying or coastal zones was due to accelerating of evapotranspiration processes that results in plants water scarcity that prohibits good vegetation growth. This was in a long-term scale. And then also was due to high or good vegetation cover act as an environmental cooling system that reduces temperature. So, and then human activities towards reducing vegetation cover enhances rising temperature. So again, when we look at NDVI rainfall Pearson's correlation coefficient, we have found out that the positive correlation was stronger than negative correlations. So the findings was positive correlation towards higher regions. This was due to low rainfall that contributes to less soil moisture content, and also imbalanced evapotranspiration that prohibits good vegetation growth. That was in the long-term scale. Positive correlation towards low-lying or coastal zones, the long-term scale. This was due to good rainfall that enhances enough soil moisture content for quality vegetation growth, including balanced evapotranspiration that regulates healthy plant growth. Again, for negative correlation, you can find out here. Showing the NDVI rainfall and NDVI temperature correlation. This has been puzzling. and both among them is noticeably affected by time scale. So at the regional scale, owing to the effect of water and heat dynamics, the climate governs the distribution of vegetation, and vegetation regulates the climatic system. At the local scale, vegetation alteration or changes is closely related to human activities. So to advance the current research findings of anywhere rainfall and anywhere temperature relationship, some more factors have to be assessed to improve the results. However, current findings provide knowledge of how decreasing or increasing other factors might have impact on other. So to conclude here, we have seen the slight decreasing trend within the study area for the NDY. So the study area found low temperature and low rainfall in higher regions. This has complicated good healthy growth of vegetation. So such zones are more vulnerable for drought impact. Anytime during El Nino, since PNG is vulnerable to El Nino, La Nino weather patterns, the drought impact can be intensified and magnified. So relationship investigation highlights strong positive and at least strong negative correlation. Specific consideration is needed either into increasing or decreasing the other variables. This might contribute to climate change and related impact. If human beings continue decreasing vegetation without any replant processes and then more emission of greenhouse gases, the future generation will experience extreme drought, flood, landslide and other related impact, and will be highly extreme if El Nino La Nino period strikes. The results prepared can be used to better understand the vegetation growth, variability and trend, including its relationship to climatic factors. So such understanding can have impact on vegetation conservation, where in return contributing to regulating the carbon cycle, regulating energy exchange within the ecosystem and regulating climate change through photosynthesis. So current results can be incorporated with other data to help solve climate change issues. This study can be used by decision makers and planners, foresters and agricultural scientists for better development within the country. Thank you, and any comments or queries to help improve our research.
Thank you very much. I would like to give the floor now to Professor Tabasam, who will be introducing the next presentations, next 5 presentations.
Good afternoon and good evening, according to the time zones. So let me introduce with you Chamani. Please apologize for if I will not pronounce your name properly. Chamaniji Malagoda, her title of her presentation is A Review of Climate Change Impact on the Coastal Built Environment. May I request to Malagoda to please, put her presentations, recorded presentation.
Hello everyone, I'm Chamindi Malalgoda. I'm attached to the Global Disaster Resilience Center of the University of Huddersfield, UK. And my today's presentation is about climate change impacts in the coastal built environment. These are the contents of my today's presentation. This paper was written based on an EU-funded research project, which is called Beacon. So I'm going to start with giving an introduction to this Beacon research project, and then I will give an introduction to this research, and then I'll move on to my research problem and the methodology, and then the findings on climate change impacts in the coastal built environment, and finally the conclusions. As mentioned before, this paper was written based on an EU-funded research project, which is called Beacon. Beacon stands for Built Environment Learning for Climate Adaptation. It aims to develop a transdisciplinary and innovative research-based learning in the built environment to tackle climate change in coastal regions. We have promised to deliver 10 outputs as part of this Beacon research project, And this paper was written based on the first output, which aims to identify climate change impact on the built environment in coastal regions. Global climate change is one of the greatest environmental threats affecting every country in every continent. If we look at the coastal areas, they are more vulnerable to climate change because in addition to changes in temperature, precipitation and more frequent flooding, they will be affected by rises in sea level and wave heights and accelerated coastal erosion and from tsunamis. The built environment consists of structures and facilities that are built in urban and suburban areas and demonstrates a high fragility and vulnerability to hazardous situations. So the built environment exerts a considerable influence over their local climate and environment, and coastal populations are already facing a range of climate-related risks such as cyclones, sea level rise, and coastal flooding. Therefore, there is an urgent need to translate awareness of climate change impacts into tangible adaptation measures. Before proposing any adaptation measures, it is important to understand the climate change impact on the built environment in coastal regions. Although many studies discuss the climate change impacts in coastal region, very few studies identify the links and their links to the coastal built environment. So within this context, this paper aims at identifying climate change impacts in the coastal built environment. Now let's move on to our research methodology. A systematic literature review was conducted in answering the research question of this study. Systematic literature review is a process that allows to collect relevant evidence on the given topic that fits the pre-specified eligibility criteria. So we have selected 3 research databases for our study: Science Direct, Scopus, and Emerald. And we identified the papers based on a search string: climate change impact, built environment, and coastal region or coastal area. And we were able to identify 305 papers. Then we did an initial screening with an inclusion and an exclusion criteria, and we were able to identify 94 papers out of the 305 papers. And then we did the main body skim reading, and we finally selected 47 papers for this study. The climate change impact in coastal regions was synthesized and summarized, and the main conclusions were that they are interconnected and has mutual impacts on each other. The links to the coastal built environment and its components were highlighted separately as shown in this diagram. You can see the color coding here on top, and all the climate change impacts on the coastal built environment are highlighted in orange. Some of the examples include coastal infrastructure damages, disruption to service supplies, decreased thermal comforts in buildings, increased building energy demands, costly maintenance over their service life, increased cost of energy, and delays operation downtime and increased cost of transportation. These are some of the examples of the climate change impacts on coastal built environment. Here you can find the key findings of this research. We have categorized the climate change impacts in the built environment under 4 headings: impact on built environment design stage, impact on built environment construction process, impact on built environment use occupancy, and impact on built environment retrofitting. So you can find all the key findings in this table. I'm not going to read out all the key findings, but more details can be found in the full paper. Moving on to the conclusions of this research, the climate change impact on the coastal built environment were classified under main stages of the built environment life cycle: design, construction, use, occupancy, and retrofitting. These thematic areas could be used as the basis to understand the current risks and thereby to develop tangible climate change adaptation measures in the coastal built environment. This is the end of my presentation. Thank you very much.
Thank you for a very interesting presentation. Let's invite the second speaker from my side. That is Farzana Sharmeen, with the title entitled Factorial Analysis of Soil Organic Carbon Draws Attention as Climate Change Mitigation in Coastal Area of Bangladesh. May I request to Farzana Sharmeen, I think so this is pre-recorded, so I request the coordinator please put her presentation. Thank you.
I am Farzana Sharmeen. Welcome to my presentation, honorable organizers and participants. Today's my part and presentation is on factorial analysis of soil organic carbon, which draws attention in climate change mitigation in coastal region of Bangladesh.
Kindly check, I cannot hear what she's saying.
My presentation is introduction here. I have conducted my research work basically on soil organic carbon.
I cannot, maybe Dr. Salvatore, can you understand?
I think it's a presentation problem. I think presentation problem, yes.
It's not proper to play this kind of presentation. So may we go to the next and later we deal with these people whose presentation is not yet presented.
Sure, Professor.
Yeah, let's go for the Akiko Kato with his presentation entitled Yoga and Disaster Prevention in Japan, Addressing Physical and Mental Well-Being Through Individual, Community, and Corporate Preparedness. Please put the presentation of Akiko Kato.
Hello everyone, my name is Akiko Kato. I'm from Japan. Currently, I'm enrolled in a doctoral course at Keio University in Japan, while working as a professional instructor certified by the Ministry of IS of the Government of India. I'm studying the physical and mental effects of yoga using a sociological approach. Today's presentation is Yoga for Disaster Preparedness in Japanese Bosai Yoga. First of all, I will explain the reason why yoga can be the key for disaster resilience and sustainable development. Generally speaking, yoga is playing an increasingly important role in health and industry. These numbers are the population of people who do yoga in Japan. Businesses and local governments are starting to use yoga for the health of their employees. Next, I will introduce 3 roles of yoga related to disaster preparedness, Bosai Yoga. First, yoga is good for mental and physical health. In an interview with NHK, Dr. Richard Brown of Columbia University said that mindfulness meditation and reduced breathing can help calm the amygdala and manage stress. Because the repertory center is close to the pituitary gland, controlling breathing with yoga calms the pituitary gland and suppresses cortisol secretion from the adrenaline cortex to reduce stress. Pranayama can reduce blood flow in the pituitary gland and reduce stress. Second, yoga can create your lifestyle healthier. This rate decreases with increased physical activity. For body, people with a larger amount of physical activity have a low incidence and death rate from such a disease and can prevent lifestyle-related disease. For mind, Physical activity has effect of improve mental aspect and daily life. Doing yoga equal increased physical activity equal promote mental and physical health. Third, yoga can be as a communication platform. Yoga can affect your mental and physical. Also, your morality cultivated by practicing yoga, not only for individual, but also for human relationship. Yoga can connect people within countries around the world. Yoga has many powers and possibilities as a communication platform. Yoga is not just an exercise or a direct effect on the body as many people misunderstand. The introduction of yoga meditation in primary and secondary education in Baltimore, Maryland, USA, has many benefits and possibilities, including significantly reducing violence and violence-related death rate. So far, I have explained three roles and power of yoga. Now I will introduce yoga as a community-based disaster preparedness. Yoga is self-help, public help, mutual help, network help. Yoga is daily preparedness leads to preparedness during emergency. Yoga is healthcare and welfare networks provide post-disaster assistance. Yoga is network help with short-term, medium-term, and long-term recovery. Combining yoga and disaster preparedness. For disaster prevention, bonding and bridging are two important points. Bonding is done by the yoga community and bridging is done in collaboration with yoga community across the country. If there is a yoga community before a disaster, even after moving to a temporary housing, you can maintain the connection between households and live a peaceful life, both physically and mentally. Since the yoga community already exists in various places, it is possible to utilize the yoga community in various ways even after disaster. Basic training program for disaster prevention yoga translates age and gender. I would like to propose both yoga in order to organize a yoga community that can be done regardless of age, gender, disability, or any background. Previous experience on how yoga helped in disaster situations in the world. Your program introduced in 2004 Sumatra earthquake. Survey on the Bosa Yoga for COVID-19 stress management in Japan. To understand the stress issues among urban residents in Japan. A questionnaire survey on stress management and yoga practice during COVID-19 period was organized by Keio University and the Yoga Organization of Japan from 15th of May to 15th of June 2020. Figure 1. Feeling stress and way to release stress. Figure 2. Performing yoga before and during COVID-19. Figure 3. Performing yoga and meditation during COVID-19. Figure 4. Timing of performing yoga and meditation. Yoga can be useful for COVID-19. Conclusion. The concept of Bosa Yoga focuses not only individual wellness, but also developing community network before and after disaster. Thank you for listening.
Thank you very much, Akiko Kato. It was a very interesting presentation. Thank you very much for enlightening most of us regarding the benefits of yoga. So let's invite the last presenter from this list, but we will go back to those who have not yet presented, especially, I think so, Muhammad Hamza Sabiri who was not able to present. The Zia Samir is not presenting really. She didn't submit anything. And I think so, Dr. Salvatore, which was the guy who was not able to present in your section?
If I am not mistaken, Mr. Muhammad Hamza Sabir.
Yeah, Hamza Sabir. Okay. Okay. So let's go for the last presenter from the list here. That is Didim Gonez Yalmez with a presentation entitled An Evaluation of Disaster Risk of Bursa, Estimation of Potential Damage and Loss. May I request to put the presentation of Ms.
Hello everyone. My name is Didem Güneş Yılmaz and I'm participating from Bursa, Turkey, from Bursa Technical University. Today I'm going to talk about my paper, which is an evolution of disaster.
Is it okay, the presentation? Volume is okay for other people?
Presentation about this and talks about it.
Yalmez, please check if the volume is okay for you. Can you hear it properly?
I get the sound. It's okay for me.
Okay, you shut down the sound, let her talk over it so we can hear her properly. Is it okay with you?
Sorry?
We cannot hear the sound of your presentation. May I request the coordinator please check if there is any technical problem?
There's no technical problem. This is the pre-recorded video that we received, Professor.
Yeah, please go ahead and check if the sound is okay.
Ganesh, please make the volume full. I can see that there is some
we cannot hear anything from here.
Half of this population live and work at the heart of the city. The district of Osman Gazi and
okay.
District in Bursa respectively. You see the table below, and Osman Gazi is on the top level, the highest density among this urban state. And Yildirim is the second highest population of this Bursa. And the two districts are located at the very heart of the city. The density of population, the quality of building stock, and the urban layout of these districts make them the most vulnerable among the other districts. The lack of green areas, the limited roadmap, and the dead-end streets in the urban quarters only increase the risk of a possible earthquake hazard. Turkey has a background with numerous earthquake disasters, and the records of these unfortunate events provide us with some preliminary numbers and brackets that could be applied to the locations with similar urban layouts. Bursa is no different than Istanbul and Izmir, as both are highly seismic urban spots. Istanbul is the neighbor in the north, and Izmir is the neighbor in the south. This paper focuses on the basic transportation lanes and building stock and similar criteria among the city. The transportation, as you see, is very highly used, and in the daytime it's very populated and it's very jammed because of these two districts are also in use as residential and also as offices and trades. There are also roads and also the railway system and instead of underground system. And also there are some bridges crossing over the non-stop roads, and the narrow streets are very susceptible to block with two cars parked into the side and just leaving one lane workable in daytime. Built environment also very vulnerable and very mixed. As you see in the images, there are some historical ones, and there are also the newly built, but also very in danger for the traditional built neighbors. And also the street layout and the building stock quality is not comparable and behaves differently during the earthquake and seismic risks. And also on the image, you see that railway system just passes by from building facades. There is also lack of parks and recreation areas in such a big two districts and heart of such a big city and populated city. The three parks are the Merino Culture Park and the Nation Botanic Park, and also the newly built and old stadium is Nation Garden. So the paper highlights the types of risk as high population density in a focus area, which causes high population in risk of disaster exposure, high population in need of temporary shelter. This means main transportation way impacted area. Vulnerable transportation network is in risk of blocking rescue teams or to cause further disasters. The average age of the building stock is high. Old building stock means susceptible to damage or to collapse. Ratio of building used between residential offices almost equal. This means no clear separation between day and night scenarios. Means accounting scenarios the likely case. Lack of green areas, parks and recreation areas. Only few large parks and recreation areas are available as serious green infrastructure. Means lack of buffer zones between likely to exposed areas. So how to study the risk factors in such complicated cases? The literature review provides some coefficient factors or some modeling numeric factors. For example, vulnerability evaluation may employ qualitative or quantitative methods, developing a model for the estimation of damage to buildings after earthquakes and mass danger management. For example, Ping proposed a model for rapid assessment method. He examined 5 earthquakes in the history of Guangdong to estimate the number of earthquake casualties. Newton used the data summaries and histograms, provided scatter flow and correlations, and revealed several potential outcome variables, including death, injuries, and total casualties and building damages. And also, other researchers utilize some decision variable model, which is expressed through a simple performance metric such as the casualties and repair costs and loss of use duration. Also, some researchers provided us some damage ratios for different building types, and also with some numerical methods, Pareto distribution and MATLAB also predicted us some casualties over 28 earthquakes in some literature sources. Based on the calculations performed by forecasting models, half of the casualties are usually certified in the first 23 hours after an incident. 80% of the total casualties are usually certified in the first 77 hours. And finally, usually after 164 hours an incident, 99% of total deaths are certified. Damage probability matrix is also another way to express the damage experienced by particular types of building. You see the tables taken from the literature sources and gives us some coefficients for seismic zones, risk, and some Mercalli numbers. And also you see the casualties for dense populations between 20 to 200 per kilometer square. This study focuses on the estimation of the possible number of population under risk, which could be injured or dead, or from debris, estimation of the possible need of temporary shelter area and the number of people, and the estimation of available areas as evacuation and temporary shelter to the actual needs. So these are the preliminary images from the study, which tells us there is no sufficient ratios for the third variable, which is stated here, areas as evacuation and temporary shelter to the actual needs. Thank you for listening, and please refer to the full paper for further details.
Thank you very much for the presentation, Ms. Yalmes. Sorry, audience, sorry for the quality of the sound was not as perfect as it's supposed to be, but anyhow, you can reach to the our website where all the presentations are available and the recording also, so you can see how she has presented. And may I request to Dr. Salvatore, please join me
Yes.
in coming up the synopsis.
Okay, so we have another presentation, right?
We'll take 2 more minutes to fix.
Let's go ahead. I said that.
Fisher, we'll need 2 more minutes to fix the
Okay, go ahead.
By
So
the time
we will not waste the time for 2 minutes. We will just give synopsis of something the presentation have done as of so far. So good. So if you allow us.
Yeah, let's have some discussion. By the time we'll fix the problem, and I'll let you know once we are done on our side. Will that be okay, Professor?
Yes, sure, definitely. No second opinion on that. So, Dr. Salvat, so please go ahead, give some comments regarding your part of the presentation done by the speakers.
Yes, we have listened to very interesting presentations.
We are done, I think.
You have done?
Yeah, we can.
Okay, let's go
ahead.
Okay,
go ahead.
Mm-hmm.
Who will be presenting now? Whose presentation will be displayed?
Mohammed, Professor
Mohammed Hamza Sabir. Please go ahead. Please put display his presentation.
Alhamdulillah, wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi ajma'in. Greetings, I am Muhammad Hamza Sabir, a student of MSc in University of Engineering and Technology, Peshawar. Earthquakes are globally accepted as a disaster. In case of earthquakes, structures usually undergo lateral loading. In lateral loading for special moment resisting concrete frames, what happens is that beams and the columns, the interface where they're joined, or the joint, the junction, it gets saturated from the force that is being transferred to it. This collection of force becomes a combination of compression and tension stresses. These cause a complex shear failure of that joint. Because of this shear failure of the local joint, a global failure of the building occurs while the other members are still intact, as can be seen here and here. The other main force resisting members are intact while the joints have failed. This has called a global collapse. So in this research, we took this beam column joint. This is the detail of beam and the column. Here is the beam detail and this is the column detail. The concrete was of 2000 pounds per square inch compressive strength, and the steel had 40,000 psi yielding strength. This was modeled in Abacus. This here shows that model that was geometrically created in Abacus. These were the boundary conditions. The upper end of the column was restricted against translation in x-axis, and the lower end was restricted against translation in x and y-axis, while it was free to rotate about the z-axis. The column axial capacity load equivalent to it was applied on the top face of the column, and the free end of the beam was supposed to undergo a load of 5.3 inches in the form of deflection. This is the a photograph of multiple mesh configurations that were used for this experimental calibration, for this numerical calibration. This shows a simple element of 2 inches by 2 inches dimensions. This diagram has elements of 8 inches by 8 inches, and these elements are of 4 inches by 4 inches. For the concrete material model, in the compression hardening, Hognestad's parabola was used. For the softening behavior was defined by Kent and Park model by this equation, and the damage by this equation. This can be graphically seen over here. This here is the compressive hardening. This is the compressive softening, and this is the damage behavior. For the tensile behavior, the hardening behavior was defined as the elastic behavior defined in the American Concrete Institute code. The softening behavior was defined by this equation over here, and the damage by this equation. This can be graphically seen over here. This only shows the softening behavior and the damage because these were the parameters that were input in Abaqus software. The concrete damage plasticity model requires these 5 parameters aside from the material parameters as mentioned earlier. These 3 parameters E, FB over FC, or the biaxial to uniaxial force ratio, and the K parameter, for these values, for these parameters, the default values were used. The viscosity parameter was calibrated by continuous trial and error, and the dilation angles were used from 30 to 40 with variation. 30, 35, and 40, all 3 of them were used. For steel, the yielding strength, as has been mentioned earlier, was used as 40,000 psi. The elastic modulus, as described by the ACI code, was used as 29,000 ksi, and the ultimate tensile strength, it was estimated based on the data available on the University of Engineering and Technology Lahore's database. Their website has the data. It was estimated based on that database. The ultimate tensile strength was used as 60,000 psi. The Poisson's ratio is also a requirement in the Abaqus. It was used as 0.2. This was estimated based on the literature. This is the behavior of steel in graphical terms. These were the results we obtained. As you can see, this blue line over here shows the experimental results. The yellow line shows the curve for the coarsest mesh size. The red curve is the relatively finer mesh, and the finest mesh is shown in green color. You can see that the coarser meshes in yellow and red color are more plastic as compared to the finer mesh. This is because if you can see these plastic strains over here, the maximum plastic strain in the coarser meshes are observed in the beam region, while in the finest mesh it's more close to the column, which is a more closer approximation of the realistic experimental behavior. This here shows the plastic shear stress in the overall columns. This is for the coarser mesh, this is for the relatively finer, and this is for the finest mesh. These are the damages that were observed. The damage as defined earlier in the material model. This is a graph of those damages occurring in those columns. We can see that in the west face as well as east and the north face, the damage pattern is quite similar to the experimental data. Furthermore, these are the variations in the dilation angle, the curves for the dilation angle. This shows the green line shows the dilation angle, the curve for the dilation angle of 30 degrees. The light blue shows, the sky blue shows the dilation angle of 35 degrees, while the violet line shows for the 40 degrees. We can see that there's not much difference, but they do need to be calibrated. Since the most plastic behavior was given by 30 degrees, so we used that. Since concrete is a highly nonlinear material and its prediction is very difficult, based on our study, it is safe to say that Abaqus software was able to effectively replicate the behavior of concrete. So it is safe to assume that if in future we employ the same software, it can be used for the correct replication or the correct simulation of concrete behavior. What we need to do is check the numerical models that we are going to be using, and we need to make sure that the dilation angle and the mesh sizes are calibrated against them. As we observed earlier, that the coarser meshes were also giving a similar load response curve, but the failure or the damage was not similar to the experimental results. So we need to check that whenever we are calculating or whenever we are performing a numerical computation or numerical simulation. And thank you very much.
Over to you, Coach. Yes.
Thank you. Okay, I think we are also missing, I don't know whether you fixed the problem, the presentation of Miss Farzana Sharmin, or maybe it was a native problem in the audio.
Yeah, we'll be skipping that presentation,
Okay.
Professor, due to
Okay.
the quality of the video we received. So.
Okay, so we will be sharing in the website.
Okay, Dr. Selvarse, go ahead and give some synopsis
Yes.
of
Yes,
your
yes, yes, yes.
interested presentation. Then I will give also a few minutes synopsis
Yes.
regarding the
It was excellent. So it was very interesting session, and we observed the issues related to the disaster from very different perspectives. So we went to the very detailed centimeter level concrete tests to to the effect on the communities, preparedness of communities, and work with communities, and making plans. How plans can help the resilience of communities. So from very strict engineering point of view, to social point of view. But I would like to also highlight the yoga component. That's unbelievable. I am Western, so I am 100% Western. So pairing the word yoga to disaster preparedness, for me, it's very surprising. That's why I listened to the presentation very carefully, and of course there is the link. I am joking, but I think there is a link. I mean, how people are prepared to disasters is very important then to elicit resilience. So of course there is a link. And also this presentation was elicited vibrant exchange of messages in the chat box. So I hope that there will be further question on yoga. I have my own question, but not for the yoga presentation. I have for the climate change presentation. And also I have my own question for Ms. Chamindi about climate change and coastal built environment, the review paper.
Okay.
So, maybe
Chamindi.
Yes, Professor Tabasam. Okay, I may raise my question. Oh, Professor Tabasam, you want to add something more?
Okay, it's like this. I'm very much agree with your analysis that from a very social perspective to a very core engineering perspective has discussed in our this what you call that session. Basically, I was amazed to see some of very interesting researches such as climate change impact on the coastal areas, and also the green areas contribution or green cover contribution in climate change impact mitigation in terms of decreasing the temperature. And one of the interesting presentation was the master plan. Call it a master plan, but it is kind of a mainstreaming DRM or climate change into urban and regional planning, or just something like that. And the rest, the yoga is very interesting element. Sometimes people think it that way. However, I have been very close to Japanese culture and have went there so many times to present and even to deliver some of the lectures. I look into this perspective in such a way that the way Japanese dealt with disaster risk management is basically mainstream in their education system. Even the children, when they go to school, they wear helmets. Because earthquakes are just like breakfast every day for them. So a small kind of fluctuations every day happen. So the preparation and preparedness become the integral part of their functions every day. And this yoga is if you are stressed, you just move your hands, right? It is a systematic way of teaching you how to do things which can increase your passions toward making decision, and that is the main, I think so, objective of including relating yoga with decision making and making you stress free, so your decision will be more effective. That's it. I think so. It's more than enough. I have added.
I agree. I think I come from Italy, and Italy is a disaster-prone country. We don't miss anything. We have volcanoes, we have earthquakes, we have floods, we have many things. But of course, the way how we face those kind of disaster is completely different from the way, I mean, compare with the way how Japanese deal with their disaster. So when we saw them, you know, reacting to a 7 or so Richter earthquake, you know, and they, you know, they are in their office, they leave the office calmly. In Italy, 7 Richter destroy half of the country, but in Japan, you know, they are prepared.
Yeah,
Maybe yoga is one component.
I'll just add very little that I am residing in the Philippines, and Philippines is not far from Japan, and we are on the Pacific Rim of Fire.
Yes, it's
where
the same
earthquakes
mechanism.
are same mechanism. So the preparedness and the proactive approach is very much in our countries, and I think so that is the integral part of their education. Even at a higher level, it is integrated in the education. Like every day in the school, they have this exercises, and they have this drills going on. So these are compulsory. These are mandatory there. So that should be considered also. So it is a variety of papers have been presented, and all papers were very constructive and contribution in the knowledge. And please give your closing or whatever questions, if somebody have, they can ask.
Yes.
If the speakers can answer those questions, it's okay. If they cannot answer, we are here. Dr. Salwarte is here.
Yes.
I'm here to answer those questions. Nothing to worry.
Yes,
Please
yes,
go
yes.
ahead.
From the audience, before we raise our own question, I have a couple. Is there anyone, any attendant, any guest here that would like to raise a question to the speakers?
There was one suggestion given here. So the financial factor need to be considered as sub-factor under social equity in housing provision. So that was the presentation by the, I think so.
Yes.
By Jaya Kodi. That is her presentation. I think so. It was on housing needs for the displaced, promoting resilient and sustainable community. If there is any, okay, your comment has been forwarded, and hopefully it will be recorded, and she can get your comment. Go ahead.
Great. If you allow me, I have a question to Mr. Sorry for the pronunciation, Tingneyuk Sekak. So I have 2 questions. Did you use NDVI annual values or seasonal? And how you manage the non-statistically significant areas? Because, you know, you are crossing at least 3 variables. So NDVI, temperature, precipitation, and even altitude. But anyway, how you manage for these 3 main variables, the non-statistically significant areas, because you might have one trend that is statistically significant cross with another trend that is not statistically significant. So how you manage these issues? Yes.
How you calibrate?
Is with us? Is the author with us? The author is from Papua New Guinea, Mr. Sekak. Okay, he's not here. So let's go to the next question.
So can you repeat your question so I can answer?
My question is issue NDVI trend. So I would like to ask whether the trend is annual or they also use some seasonal analysis. So it's the annual mean, or they use seasonal mean? Seasonal means.
No, he's as long as I saw him presenting, it's more on a yearly basis, just like projections.
Okay.
Is on a projection base.
Okay.
That how the trend of use. You can say that the use of land has been changed in future. How it will change in future. If it was green before, what is the trend of changing in decreasing the green and increasing the brown areas? Your question is very valid, because greenery is not the only thing there. There are build-up areas, or we can say urban morphology or rural morphology of the areas need to be considered there. So they can be categorized accordingly, and we can see the real proportion of the vegetation. It is the zoom out area at the moment. So I think so they can answer those questions later. So go ahead.
And then another question is for the work of Ms. Chamindi. Review of climate change impact on the coastal built environment was very interesting. When we talk about climate change, what matters is the time span of our analysis, because, you know, if the time span is short, we talk about variability, but we need to talk, if we want to talk about climate change, we need to increase it. So I wonder whether in your analysis, you consider the time domain of the papers. I mean, what was the time span of the analysis of the paper that you have reviewed? Because sometimes many papers, they talk about climate change, but then when you look at the data, I mean, it's just 10 years long data, or even 20, but 20 is not enough to talk about climate change. But we should talk rather about climate variability for that time span.
Yeah, we considered the time frame, but my first author of this paper is Shavindra, and she's also here with us. Maybe she can give you the exact time frame if you want.
Yeah, curiosity.
Shavindra, are you there?
Hello. The main aim of this paper was to evaluate the impact on the built environment aspect. And when we went through the literature, the main problem was many literature and many findings speak about the climate change impact, but very limited studies identify the direct links to the components of the built environment. So, and there was a lot of papers on climate change impact. And as you have seen, we have followed a systematic review. We basically identified three from the papers from 2017 first to 2021, and then from there also I screened the papers for the during that were published during the last 3 years, and then also I came up with the 300 odd papers. So it was a very high count, but then what I noticed when I did this systematic review for several times, because I categorized first in the study the climate change impacts under 5 main categories: the physical impacts of climate change, economic impacts, social impacts, the environmental impacts, and the institutional impacts. And then under each of these categories, the small impacts that were identified under the thematic analysis then were linked to the small components of the built environment.
Okay, thank you.
Thank you, Shavindra, and thank you very much for the question. Thank you.
Curiosity.
Thank you.
For me, time, I'm a geologist, so for me, in geology, time is one of the main components. So for me, time is always there. I don't know, any aspect of any kind of analysis, for me, time is one of the main variables. That's why
Professor Salvatore, your time is not their time.
I know. It's not the same time, but the frame is that one. The
your
variable is that one.
Precambrian, Cambrian, Ordovician, Stonian, Devonian, Carboniferous. That's your time.
I know.
Their time is 24 hours, 1 month, 1 year.
I know.
Your recent is 30,000 years ago. So I understand. Literally, time is very important, and time scale is very important in geological analysis or geotechnical studies. So, however, their studies are more on projection based. The study's impact of climate change is always done on the projections of 20 years, every 20 years. Well, the latest is 230, and after 230, 250. So with the pre-industrial climate availability, climate centigrades, or you can say a temperature, pre-industrial temperature, and we are trying to not increase it to more than 2 degrees centigrade. So what they are trying to do, these good researchers, they have done incredible job. You notice that how many papers they have read?
Yes, of course. They're more than what I read in 1 year.
Yeah, that's what I always tell my students in research methodology: read, 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 and read. That is the solution for you to find out what is the existing problem and how you will solve that problem. So usually I notice that they have first 400 papers, then out of 494, out of 94, 47. It's interesting because acknowledging the research of people or other researchers is also a very big challenge to understand what they have done. So I think so incredible job done. They deserve some kind of really applause from our side. So go ahead, Doc. Any other questions from the audience?
These were my questions. Any other question from the audience?
No, from your side it's okay because I don't see any question popping out here.
Yes, for me I am okay.
No, so far so good. There is no question. And if you have, because we still have around 7
minutes. Yeah, 7 minutes.
Yeah, 7 minutes. And we can shed some light on some of the interesting presentation, because 2 presentations were not done. So maybe which one was not done is Zaya Samir, an exploratory study on feasibility of materials for refugee relief settlements. I don't know if there is any kind of abstract available. At the moment, I don't have access right away. I do, if I have, I could have just give a gist of that explanation. So let's go to, seismic performance of RC building with concrete made by using different waste material. It was an interesting paper. I'm just interested to look into that particular paper. When you are using used cables and other kind of material, what you are trying to mix it with? When you say addition, adding in what? Can somebody, whose paper
is the author here?
Yes, sir.
Yeah,
So we actually added it as a replacement in concrete mixtures, replacement of either cement or fine aggregate or as coarse aggregate. For example, electrical cable waste was used as a replacement for fine aggregate. So like that. Okay,
fine aggregate. Fine aggregate is clay.
Yes.
Soil. And then after that, you have your concrete is has a pebble. So you have also gravels, no? And then you have a cement. So there is a ratio 1 to 3. Let's say is for 4,000 or 6,000 psi. So let me go to this one. That you have different kind of curves. We have seen the curves, and you have done what kind of test was tensile test or compressive strength test?
So actually, due to COVID situation, we were not able to go to the labs, but we did the analysis on a software called ETABS. So we did a seismic analysis there on that software using.
So it's more on shear strength and tensile forces test.
Yes, so it's on the effect and on the behavior of the building when an earthquake, on the impact of an earthquake.
But your basic objective is to know the material strength. Okay, when a fine material, you have different properties to know, such as what you call that. Soil mechanics properties. Dr. Salvador, do you still remember your soil mechanics?
Yes, I did it. Geotechnics, 1 and 2, I did it. Applied geology 1 and 2, I did it.
Yeah. So there is a lab test for that. Properties of soil properties, which has an index. percentage of porosity, permeability, and then there is a one test you make some kind of noodles and you check the plasticity and elasticity. So how you relate it with your cables material? Do you have to crush it before?
Yes, sir. We, in case of electrical cable waste, we crushed it into a very fine particle and then we added it into the concrete mixture. We studied various papers or research papers on this, which concentrated on the strength parameters of the mixture, but we focused on the seismic parameters like displacement and shear, story shear, everything like that. We did all that. We did our work on that.
Good enough that, but the most important part in that material feasibility is always the economic factor of buying cement or buying your mixture. So do you have any idea that how much it costs? And otherwise I will be going and looking for used cables and nobody will give me cables. So what I will do?
So we are still to work on the economic factor of that. We are still working on it.
Well done. Keep up good work. And we are the professors around. If you need any kind of assistance, we are always pro bono. We don't charge anything to students.
Yes. Thank you, sir.
Doc, your any interest, any presentation of your interest, please. I'm looking if there is anything related to geology. Seismic is geology, of course.
Yes, but you know, in my career, to follow funds, I have to go from the underground to the surface. You know, so now I left the underground in my bag.
So there is an interesting Farzana Sharmin has an interesting presentation also, factorial analysis of soil organic carbon. Draws attention as climate change mitigation in coastal area of Bangladesh. May I request the candidate or not candidate, the speaker, to give us the gist of your, what is your output? I mean, which can help us to make a decision, let's say. Please open your, unmute.
Could you hear me?
Yes, now yes.
Yes, I am really sorry my presentation was not working there, but my main focus was that soil organic carbon, which is very vital for restraining soil carbon and which can play as a climate change mitigation in future. In the coastal region specifically, I have been tried to draw on my presentation. And also in my research work, basically, I have been trying to conduct my research land use pattern and also type of land use which we are used. So after accomplishment of my study, I have found the result. Basically, double cropping pattern and agroforestry is the best for sequestering or restraining more carbon in the soil, which will make carbon-free our atmosphere, and it will be very vital and effective steps as a climate change mitigation.
Thank you very much. So nice of you. Now we are running out of time, Dr. Salvatore, please.
Thank you.
Go and please to ask our coordinator to help us for the closing of this session.
Sure, Professor, I'm here.
Do we need to take a photo of everyone or we just...
Firstly, let's have a final remarks from you, Professor Raja, then Professor Salvatore with final remark. Then we'll have a group photo if all of are fine with to open the camera.
Okay, my remarks is integrated remarks in terms of these all papers have been presented very well in terms of integrated knowledge, I can say, a knowledge which can be used for all of us from different disciplines. The essence of this knowledge dissemination is that we can touch each other's areas of expertise, and then we can learn from each other. I think so. You have seen or you heard different aspects of our reaching, the mitigation, preparedness, and also the rehabilitation, rebuilding of our structure, build back better, and those kind of strategies we have adopted in these papers, and it reflects those things. And I was very astonished to see that how people are trying to relate their expertise in particularly in reaching those 4 objectives of Sendai framework, and also the sustainable development goals, especially the goal 11 related to cities protection, and also goal number 13, which is related to climate action. So I will like to congratulate everyone, especially starting from social ties. Yoga is not just only the exercise. I will repeat what was said by Akiko. It is a social linkages thing. In Japan community, the houses are in terms of buildings, and there is a social area where people socialize. So if this exercise is done in those areas, people are socially related with each other. And when you know each other, you know each other's strengths and weaknesses, and then you can fill in the gap when these kind of elements or incident happen. Thank you very much. I would like to congratulate all of you for giving us such a constructive, productive papers.
Thank you, Professor Raza. Now over to you, Professor Salvatore.
Oh, I will be very short. We are running out of time already, 3 minutes. Me too, I would like to congratulate with all presenters and for the very nice presentation. I would like to mention the very high quality of presentation. I think in terms of really quality of graphics, quality of synthesis, they were all well done. I think this should be remarked. From my side, I already told my thoughts. There was a lot of diverse views on the issues of disaster and how to recover after disasters. So again, congratulations to all. I hope to see you all in person somewhere in time and in space. And I hope you are doing well. You will be doing well in this period of crisis. And we all hope that we are on the right side of this bell curve. And with vaccination time coming, we hope to travel again, come back home. I am 2 years already far from home. And again, congratulations and see you. And thank you for the organizers. And thank you, Professor Tabasam. Thank you, everyone.
Thank you, Professor Salvatore. Now, if that's fine with all of you, do you not mind to turn on your camera so we can have a quick screenshot of all participants? Yes, and we are really excited to see you in person in coming year. We hope like we can organize in-person conference, our next conference. Okay, let me take this. Yes, that's perfect. Thank you. With this, we have come to the end of the session. Now, I'd like to request you all to be present at our next keynote session, which will begin at 7:30 Bangkok time, which is after 10 minutes, followed by the closing session or closing ceremony of Second International Symposium on Disaster Resilience and Sustainable Development. All remaining event will be hosted in Hall 1. And I am personally thankful to our co-chair for having such an interactive and full food session. Now, lastly, thanking our co-chairs, presenter, and participants for their valuable presence. I'm signing off from this hall and looking forward to see you in Hall 1 for our keynote session and closing ceremony. Thank you all for your presentations and presence. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you very much,
all.
everyone.
Thank you very
Thank you,
much.
Doc. Salvatore, thank you very
Thank
much.
you,
And
Professor.
thank you, the
See you.
coordinator.
Thank you very much.
Thank you. Thank you, everybody.
Thank you very much.
Welcome, welcome. All welcome.
Yes. And I really appreciate your warm comment.
Okay. You're welcome. You're welcome.
Yes, about
you deserve that. And
yoga.
everybody deserve a good comments because we need you to grow and become the essence of this nation.
Yes,
This globe.
Yes, of course.
Okay, take care, guys, and have a very great day from my side.
Thank you, sir. Bye-bye.
Bye-bye. Tata and sayonara.
Sayonara.
Ciao a tutti.
Participants.